Ok, désolé pour le petit problème technique. Donc on va recommencer. Les premiers groupes cet après-midi vont vous parler de tous les nombres avec pi. Ce sont des groupes de Palo Alto et San Francisco.
Bonjour, nous allons vous parler des nombres avec pi, mais on va présenter en anglais parce qu'il y a une partie de nous qui ne parle pas français. Donc, hi, my name is Stephanie.
I'm Juliette, and we're from the Lycée Francais San Francisco.
I'm Rylan, and these are my classmates from Palo Alto.
Hi, I'm Emily.
I'm Raina. And I'm Emmy.
Okay, so our problem is called all numbers with pi, and our goal is to calculate as many numbers as possible using only pi, the floor function of e, which we're going to explain later, and the operations of addition, subtraction, multiplication, and division. And we can only use pi and the function of e 3 times. So using those numbers, we want to try to find as many numbers as possible, only the positives. The negatives would be the same thing, just with a negative. And if possible, try to identify a pattern between all those numbers.
Okay, so you guys probably all know what pi is, but it's an irrational number. So a number that can't be written nicely as a fraction. And then it's infinitely long, so we didn't write the whole thing, but these are the first couple hundred digits.
Okay, so the floor function e, what it does is it basically takes like a non-integer or a decimal number and it rounds it down to the nearest integer, even if it's a negative.
Okay, so if you have like negative 15.6 about, then it'll round it down to negative 16. And then if you have a positive number, so let's say like 7.5, even though normally it'd round up, if you're using e, then it'll round it down to a 7. But if you have an integer already, like 9, then it won't round at all, it'll just stay there.
Okay, so we basically took pi and took the floor function of it. So everyone knows that pi is basically 3.14, right? So because of the floor function e, we rounded down to 3. And the same goes for negative pi. We round it down to the nearest integer. So that would be negative 4, and then finding the negative of that would be positive 4.
And we kind of just use these two as our bases and then try like different operations with them to make larger numbers.
So since we can only use pi 3 times, we kind of used as building blocks, and we started by creating numbers where we only use 2 times pi. And so this is the list of all the numbers of only 2 times pi.
Donc après, notre méthode, c'était d'utiliser ces nombres avec 2 fois pi dans l'expression et les utiliser avec les nombres avec une seule fois pi dans l'expression, donc 3 et 4, et donc de les combiner pour fabriquer de nouveaux nombres. Donc on a fait plus 3, moins 3, multiplié par 3 et divisé par 3, et pareil avec 4. Et on a aussi remarqué que pour certains nombres, parmi les plus grands, quand on multipliait par pi le nombre, et ensuite qu'on prenait la partie entière, ça ne donnait pas forcément le même nombre que quand on multipliait par la partie entière de pi directement. Donc du coup, on a utilisé ça aussi, et on a aussi fait multiplier par moins pi, et pris la partie entière et mis ça au moins. Ici, le n représente le nombre avec 2 fois pi dans l'expression.
So we use this methodology to create a bunch of numbers with 3 times pi, which was the maximum, and it created a long list of numbers that we can't fit onto one slide. So, yeah. And also we were able to recreate the same number using different multiplications using different building blocks, but we didn't include them on the side because it just keeps repeating the same number with a slightly different variation of the calculation.
Basically, here are the numbers that we found. Black are numbers numbers that we found, and red are the numbers that we can or are impossible to find. So as you can see, we were able to find numbers from 1 through 32, 36 through 41, 48, 51, 50 through 52, and 64. And 64 is pretty much the largest integer that we can make using maximum of pi's and the floor function e. So that would be 4 times 4 times 4.
So lastly, we decided to go a little farther and use exponents as another operation. And the reason exponents wasn't in the subject because it's essentially the same thing as using the normal operation multiplication, but we use pi more than 3 times. So we use exponents to create a bunch more numbers with only 3 times pi. And we create a huge list of numbers. And there's even more that aren't represented in this table. And actually the numbers were so long that there's not enough room on the slide to put them. And so as an example, 81, we created 81 doing 3 power 4, and so on and so forth for all the numbers.
Donc on pouvait utiliser les nombres avec 2 fois pi dans l'expression et les mettre à la puissance 3 ou à la puissance 4 pour utiliser 3 fois pi. Mais on pouvait aussi prendre 3 et 4 et les mettre à la puissance de nombres avec 2 fois pi. Donc comme on a trouvé 36, donc ça pourrait faire 3 exposant 36 qui est un très grand nombre.
Est-ce qu'il y aurait des questions?
Moi, c'est pas une question, je veux bien revoir tous les noms que vous avez trouvés, s'il vous plaît. On met les tableaux. Ouais, non,
Du coup, d'autres questions?
on trouve les mêmes, je vais vérifier, bravo. J'en ai pas plus que vous.
Bravo.
J'arrive.